Hello everyone, I hope you all are doing great. Today I'll discuss about the VLSM, Variable Length Subnet Masking. So in the previous video we discussed about the subnetting and we talk about the all at the equal size subnetting, how we can do the equal size subnetting, and today we will discuss about the variable size subnetting, so which called the variable length subnet masking. Let's see what we will cover today. So I will start very briefly talking about the what is VLSM, and then we will see why actually we need the VLSM, and then I will show you 5 simple steps to do the VLSM so that you never do mistake when you design your IP address using the VLSM. So let's see what is VLSM. So we know the equal size subnetting. We discussed the equal size subnetting in our previous video. So the VLSM is actually the different subnets can have different lengths. Different subnet can have different mask. So in the previous video when we discussed about the subnetting, we saw all the subnets had the same mask or same length. So today the VLSM is actually give us the opportunity to different subnet can have different mask. So let's have an example. What does it mean by the different networks or different subnetworks can have different mask? So let's consider we have a network 200.10.10.0/24 and we want to divide it in a different subnets with different length. So consider when we divide, we get one subnet which is subnet mask is 25 and another two subnet, these two, the network length or the subnet prefix length is 26. So we divide this one network into 3 different networks, and out of these 3, one of them has the length is 25, other 2 has the 26, and you can see the size also. The first one is the bigger size, which you can have 126 addresses, and other 2 we can have 62 addresses. Okay, so that means in the VLSM we can have different subnetwork with different size. So now we know what is VLSM and what is the difference between the equal size subnet and the variable length subnet masking. So now let's see why actually we need the VLSM. Consider you are working in an organization and this network is your organization's network, and they have the different department. So like engineering department, and this department is estimated number of hosts is 55 hosts. And then you have the human resource department, sales department, technical support or tech support, right? And then also the 2 routers are connected each other, that has also the networks, and these network can have maximum we need only the 2 IP addresses. So you can see in real scenario, real networks or organizations, they have different networks with different size. So now if we look at how many networks we have, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have the 9 subnets we need. So if we make it equal size subnet, so we need the 4 bits. So 2 to the power 4 is 16. So we need the 4 bits for subnetting. So if we borrow the 4 bits, so our actual network is 172.16.0.0/22. So this is the 22 bits is our actual network. Then we borrow 4 bits for subnets. So if we borrow the 4 bit for subnet, we can have 16 subnetworks, and the remaining 6 bits for our host. So each host we can have 2 to the power 6 minus 2, which is 62 IP addresses, or 62 hosts we can assign each of the network. So now if we assign our 9 networks with these 9 subnetworks, so let's see what happened. So consider we assign the first subnetwork to engineering department. And engineering department, we have 55 devices or 55 hosts. So out of 62, we are allocating 55. That means we are using almost every IP addresses. But if you look at the network between router 1 and router 4, or router 1 and router 3, we need only the 2 IP addresses. One is the port for router 1, another one is the interface for the router 3. We need only 2 IP addresses, but we have IP address available for this network is 62. So 60 IP addresses we are not using. So now if you consider we have 1, 2, 3, 4 networks, all of these 4 networks, we need only 2 IP addresses for each network, but we are allocating 62 IP addresses. That means we are not using lots of IP addresses. We are not using. We are wasting the very precious IP addresses. So VLSM actually give us the opportunity to overcome this issue. So it will give us to design IP address more efficiently, so that we can reduce the wastage of the IP addresses. Now let's see how actually we can do the VLSM, Variable Length Subnet Masking. So consider we have this network. So we have 1, 2, 3, 4, and the network between the 2 routers. And the network A has 25 hosts. Network D has 6 hosts, C has 10 hosts, B has 12 hosts, and the given IP address. So the given network is 192.168.10.0/24. And now I will show you practically how can we use all the step I said, the 5 steps, and we can find the VLSM. We can find the different length or variable length networks for each of these IP networks, so that we can reduce the wastage of the IP address. So what are the steps? So the first step, we need to find the largest network or shortest prefix length. So for example, in these networks, we have the largest network is A, which is 25 hosts. So step 2, divide the address we have into the equal size subnetworks. So we already know the equal size subnetting, right? So in the previous video we saw that. So we just need to do the equal size subnetting based on our largest network. So when we are done with doing the equal size subnetting, then we will allocate the largest subnetwork from the beginning of the IP address block. So the subnets we get in the first block, we will allocate for the largest networks we find in step 1. Then the fourth step is, now we need to choose the first unallocated address. So consider we divide into the 8 subnetworks. So the first one we allocate out the largest network, and then our remaining 7 we will select the first one, or the numerically the lowest unallocated address. And then we just repeat the step 1, step 2 and step 3, and you will do the subnetting or VLSM, variable length subnetting, without any mistake. Okay, so let's see the example again. So the network we saw before. So now the largest network is network A, right? So which is the 25 host. All others are smaller than this network. So to 25 host, how many bits we need? So 2 to the power h should be greater than 25 or equal, right? So 2 to the power 16, 2 to the power 4 is 16 and 2 to the power 5 is 32. So 2 to the power 4, that means the 4 bit is not enough. We need 5 bit. Then we can have a networks which is useful for largest one. So if we need the 5 bit for the host, then how many bit we can borrow? We can borrow only the 3 bits, because this is our network, and out of this network we have 8 bit for host. Now we said we always borrow from the host bits to create the subnetworks, to find the subnetworks. So out of 8 bit we need the 5 bit for this largest networks. So 3 bits is remaining. So 3 bits we are borrowing for the subnetwork. Okay, so if we borrow the 3 bit for subnetworks, so we can have 8 subnetworks. So 000, then 001, 101, right? So gradually all are 1, all 0 to all 1. So we get 8 subnetworks. So now what is the new prefix length for all the subnetworks? The new prefix length is 24 plus 3, so 27. And this is what all are the 27 bits. So we created equal size subnet. All are equal size, or everyone is 27, right? So we created equal size subnet from our given networks. So we said the first 3 step, 1, we select our largest network, and then based on this largest network we divided the given network into the 8 subnetworks. And the third step is, now we will allocate or assign the first network to this largest network. So first subnetwork, so which is 192.168.10.0/27. Now we are allocating to the network A. So we are done first 3 steps. Okay, so before doing the remaining part, let's show you a trick how we can get from without converting every time from binary to decimal, binary to decimal. So how can we get directly to the decimal number? So we said we need the 5 bit, we need the host bit. So 2 to the power 5 is 32. So that means the block size is 32. So when the block size is 32, that means all the subnetwork is actually increasing by 32. So that means the subnet is actually increased by block size. So if it is the 4 bit, then block size is 16. If the number of host is 6 bits, then the block size is 64. So in our case, so our number of host bit we saw here in the previous slide, right? We saw here the 5 bits. So if the 5 bits is the number of hosts we needed, so our block size is 2 to the power 5, which is 32. That means 0 plus 32 is the next subnet. Then 32 plus 32, 64 is the next subnet. That means next subnet is the addition of 32 of the current subnet. So we don't need to do if you do more practice, it will be more easy for you. It will otherwise it sometimes take more time, right? So now you can do directly binary, directly to the decimal. Okay, so now let's do the remaining part of our VLSM for all other, to find the network for all other, to find the subnetworks for all other networks. Okay, so what is the fourth step? So fourth step is saying we need to take the next first subnets, those are available. So we have available networks or subnetwork is 192.168.10.32 until 192.168.10.224. So out of this, the 192.168.10.32 is the first subnetwork or the numerically lowest subnetwork, because all are the bigger than this one, right? This is 32, then 64, then 96, so all are the bigger. So sometimes that's why it's called the numerically lowest subnetwork. So now we will select this networks or subnetwork and we will look for the next largest network in our enterprise network, so which is 12 or the network B. So for network B we need number of host or host bit 2 to the power h should be greater than or equal to 12. So 2 to the power 4 is 16, 2 to the power 3 is 8, so 3 bit is not possible, we need 4 bit. So if we need the 4 bit, so 2 to the power 16, that means actually the network C and network B both we can allocate by using this number of host. That means the number of host bit is 4. So from this network, this is /27, that means 5 bits for host. So now we need 4 bit for host. So 1 bit we can borrow. So if we borrow 1 bit, we can make it only 2 subnetwork. So now our network is 32 and block size is 16. So what is the next subnetwork? 32 plus 16, which is 48. So we don't need to do calculation again for the binary and then binary to decimal. We can directly find based on the block size. So now we allocate these 2 networks to 2 different network, class B and class C. See, gradually we are populating all, or gradually we are getting the networks or subnetworks for all of our different departments or different networks, right? So the next largest network is D, which is 6 host. So for 6 host, we need the number of bit, host bit 2 to the power h should be greater than 6. So which is 2 to the power 3 is 8. So if we take the 3 bit, so this is the our next lowest available subnetworks. So and which is /27, that means 5 bit for the host, but now we need only the 3 bit for host. So we can borrow 2 bit for 5 minus 3, 2. So 2 bit for subnetworks. So if we borrow 2 bit for subnetwork, then we can get 4 subnetworks. And again, how we get the subnetworks? Our base network and then add up the block size. Block size is 8. So 64 plus 8, 72, 72 plus 8, 80, 80 plus 8, 88, right? So we got all the 4 subnetworks. And out of this 4 subnetwork, the first subnetwork or numerically lowest subnetwork 192.168.10.64 we allocate to the network D. So the remaining network is only network E, and this network we need 2 hosts. Okay, so for 2 hosts, how many bit we needed? So 2 to the power h should be greater than or equal to, so 2 to the power 2 is 4. So we need the 2 bits, and you already know why we are taking the 2 bits, right? So 2 to the power 2, and then we said 2 the formula 2 to the power h minus 2, right? Okay, so now we are selecting the next available. So the next available lowest subnetwork is 192.168.10.72/29. And how many bits we can borrow? We need 2 bits for host or the IP addresses, and we have 3 bits available, so 1 bit we can borrow. So if we borrow 1 bit, we will get the 2 subnetworks. So 2 subnetworks, and block size is 4 bit. So 72 plus 4 is 76, and the prefix length was 29. Now is 1 more bit we are borrowing, so 29 plus 1 is 30. And the first subnetwork 72, also the numerically lowest subnet, we are allocating to the network E. So now you can see we are allocating the different size network to the different size of your physical network, your enterprise network, right? So some are 27, some are 28, 29, 30. So this is why we needed the VLSM. And if you look at here, we have all of this network, all the black networks, black font, are available for future use. So you are saving many IP addresses for future use. So VLSM actually increase or give us the scope to efficiently allocate the IP addresses. So by using this simple 5 steps, basically 3 steps, and then we need to repeat it. So if you follow these 3 or 5 steps, and you will never do mistake when you calculating the VLSM, variable length subnetting. So thank you very much for watching the video.